Okay, welcome to problem number 4 here. I preloaded the first function for you, and I'm going to type in g of x into the calculator here as f2 of x. Just want to make sure you understand it's negative. To get the absolute value, you can hit the lobster button, and you can go right into here and click on that, and that'll pop up absolute value. So we got the absolute value, or the opposite of absolute value of x, and then we have plus 5. All right, I want to make sure that that's the one that we had there. There we go. So what we're doing in this problem as we graph both of these is we're going to talk about the distance between these two functions. Now remember, we're always talking about the y values when we say a function's value. So if I just go right here, let's just call it an x value of -2. There is a vertical distance here between these graphs. Now obviously when we look right here, the red graph, or the absolute value function graph, is higher, has higher y values than the cubic graph here. So that distance would be f2 minus f1, whatever the values are to get the distance there. Well, as you can also see, that is going to happen over here if we just check this value, but that distance is much larger. So it really depends on the x value. That's weird, depends on the x value. Of where you're going to have an answer here or an interpretation of this graph. So look right around an x value of 0. As you can see here, the distance between blue and red here is actually blue positive or higher than the red graph, which wasn't happening over here. So you got to understand kind of in the context of the question what your answer is going to be. So that's a lot of talking, but I want to kind of have you understand it. So what I want to do here is I'm going to show you, if you go, you can see that on the left side here, if we go to doc, and you don't have to do a split screen, but I just like doing it so that you can see it. So if we go to page layout and we do our custom split, and over here, if we add a graph, we're going to type in the difference of the two. Now here's the deal. We are looking for the difference of the graphs to be, I believe, 7 for this problem. Well, this one's kind of funky to look at because if you look right here, you could definitely see up here where the graphs could be 7 units apart. But I think if you look somewhere else, you could see where they could be 7 units apart. So we're going to have to talk about that. But since up here, let's just start with this one. I'm going to type the blue one in, f1 of x minus f2 of x. Now obviously blue is the cubic one, and red is the absolute value one. So I'm just going to type that in, and that's going to show me this function. Now before we carry on, I want you to understand what this function means. Basically, it's tracking the difference or the distance, the vertical distance between these two functions. So just pick a point right now of, let's say, -1. If we look at -1 right here, the difference between these graphs has a certain value. Let's pick another one. What about -2? If we pick -2, I'm just going to kind of guess right here. That looks like the distance, 1, 2, 3, 4. The distance between these graphs is about 4. So if I go to -2, I'm actually going to 1, 2, 3, 4 have a value of like -4. Now, why is that a negative? Remember, we put in f1 minus f2. So in this situation here, at an x value of -2, f2 has a larger value than f1. So that's going to show up as a negative over here. Now, if I look at a value of 0, think about the value of 0 here. Let me see if this will let me zoom in. Hold on a quick second. Sorry. Okay, I'm gonna zoom in a little bit on this graph. Okay, so at a value of 0, we have a y value of 3. Well, what that means is over here, at a value of 0, these graphs are a distance, these functions are a distance of 3 apart. So this is a little bit trickier one to see, but that's exactly what this is tracking right here, the distance between them. Now, it doesn't make sense to have negative distance. We definitely know that. But this one's going to have some negative distances because the x values here, it's a little complicated situation that sometimes the distance is the red, as what we would call the big function, and sometimes the blue would be the big function. So that's why it's a little tricky. All right, but let's just try to answer this question, and hopefully some of this made sense. And, you know, it's obviously going to make more sense in a more simple problem. But if I go to, I'm sorry, didn't mean to do that. If I go to this one right here and I hit tab, let me, you can always do control, watch this, you can do control, escape, because I didn't mean to zoom in on that one right there. But if I hit tab, now I can put in another function, and since this one said 7, I'm going to type in a 7 here. And that'll give me not nothing. It actually is there. If you grab your graph and you pull it, it's right there. Okay? So I can see right there that it actually is a value of 7 on this. Well, what does that mean? That means that, let's calculate the intersection point real quick. Analyze our graph, go to our intersection, and we are looking for, between here, and boom, they give us that intersection point. Now, hold on a second. Hitting a couple things I don't mean to hit here. Be patient. I want to grab this other text. There we go. I want to get this out of the way. So here's our ordered pair, and if I hit plus when I hover over that, I will see more decimals if I need to, okay? But we have 3 there, so we're good. So what does this mean? That means if over here you go over 0.272, right here, 0.272, that's where these two graphs have a vertical distance between them of 7 units, okay? Now, that's because the blue, keep calling them blue just for ease of explanation. That's why the blue one is on top of the red one to give you a positive difference there. Well, down here, obviously, if I did blue minus red, I'm going to get a negative value of 7, which is represented our distance. So on this one over here, I have to actually add another line at y equals -7. That's one way of doing this problem. So if I hit tab and type in -7, okay, I have another intersection point right here. So if I go ahead and calculate that one, analyze graph, and get my intersection there, I have another spot here where the graphs are 7 apart, okay? Because that's what this tracks. This entire function tracks the difference of the graphs. Well, if the difference is -7, that's just because we typed in the blue minus the red. So that actually is going to be at an x value of look at that, let's just call it -3.8. Look at this, 1, 2, -3.8. Like right here, these graphs have a vertical distance of that far apart. So let me see if I can actually use this tool here. This might help in the explanation. I'm not sure. Let me try. Let's use yellow, okay? But at -3 point here, like right here, yeah, they're not going to let me draw on this graph, so that's okay. But basically, at -3.8, we have a difference of 7, and then also here. Okay, this is a lengthy explanation. I talked a lot. Maybe I'll do check the videos because I might do one that's a little simpler, and maybe it'll make more sense there. But this was a neat problem that I wanted to take some time to talk about.